In Unit 2, Objective 8, we're graphing systems of inequalities. Now, when we graph inequalities, we're going to have shaded areas. And since we're graphing two different inequalities on the same graph, what we're looking for is the intersection of the shaded areas, where the two shaded areas overlap. Now, the complexity of the problem is going to lie entirely in how easy or how hard the functions are to graph. So problem number one, my first inequality is y is greater than x plus 3 quantity squared minus 2, which we remember the characteristics of the equations or the inequalities, we know this is going to make a parabola. And it's going to make an up parabola because it's positive. So we already know one thing. It's going to make an up parabola. We also know the vertex of this up parabola is -3, -2. So we might as well put that on the graph. -1, -2, -3, -1, -2. Now, because the leading coefficient is +1, we can follow that pattern of over 1, up 1, and then follow the odd numbers, over 1, up 3. And then if we want, we can do one more because we have room, over 1, up 5. Now, this is just a greater than symbol. It's not greater than or equal. So I'm going to do my very best to sketch this parabola, but without making a solid line because I need to make it broken lines. So here we go. Not bad. So, there's my sketch of the first inequality, the quadratic one. But I still need to figure out, where do I shade? Do I shade on the inside or the outside of this thing? So I'm going to use a test point. By my drawing, I know 0, 0 is not on this parabola. So that's what I'm going to test. It's an easy point to test. Let's test 0, 0. Which means I'm just going to plug in a 0 for the x, and I'm going to plug in a 0 for the y, and I'm going to see if it's a true statement. So if I plug in a y value of 0, I get 0 is greater than. Now if I plug in an x value of 0 also, 0 plus 3 is 3, 3 squared is 9, 9 minus 2 is 7. So I get a statement that is saying 0 is greater than 7, which is obviously a false statement. So when your test point proves out to be false, you shade the area that does not include the test point. And so in this case, it would be inside the parabola. Now I'm just going to do it really lightly because you know I've got another function that I've got to put on this graph. So now it's time to start working on the other function. I'll do that in a completely different color. I'll do it in red. Now this one's an absolute value function, and the leading coefficient is -3, so you actually know it's going to be something that makes a downward V. Now the first thing I would do to this is I'm more familiar with the constant being at the end, so I'm going to rewrite this thing. Y is less than or equal to -3 x plus 2 in the absolute values, and then I'm going to put the plus 5 because it's a positive 5. at the end. Now I know the vertex of this thing. The vertex is at -2, +5. So let's go ahead and graph it. 1, -2, 1, 2, 3, 4, 5. There's the vertex. Now the slope is -3, so down 3 over 1, down 3 over 1. Go the other way, down 3 over 1, down 3 over 1. Now, since it's less than or equal to, I can use a solid line. I don't need to use a broken line to represent this graph. Now, I get really close to 0, 0 on this graph, but I don't hit it, so I'm going to use 0, 0 again as another test point. So if I plug zeros in for both x and y, I get a statement that says 0 is less than or equal to, I'm going to plug it in here actually. My y is 0, x, 0 plus 2 is 2. The absolute value of 2 is 2 times -3 is -6 plus 5. 0 is less than or equal to -1, which is also a false statement. So again, I got a false statement when I tested 0, 0, which means I shade the area that does not have 0, 0 in it. So in this case, it would be the inside of the V. Now, the big question is, where's my overlapping area? Because that's actually the solution to the problem. The overlapping area is the area that's inside the V that's going down, but it's also inside the parabola that's going up. So, the overlapping area appears to be this area right here. And that would be the solution to that inequality. My second and final example for Objective 8 again looks at another parabola. Just by the characteristics of the inequality, we know it's a parabola, we know it's up, and we know its vertex is at -1, 0. Now, because the leading coefficient is +1, I can do the pattern again. Over 1, up 1, over 1, up 3. Now this time it's greater than or equal to, so when I draw the parabola, I actually use a solid curve, not a broken curve. But because it is an inequality, we need to figure out, do I shade inside or do I shade outside? I could test 0, 0 again, but this time I want to give you a true answer. So let's test the point right here, 0, 5. Let's test 0, 5. Everywhere we see an x, we're going to plug in a 0. Everywhere we see a y, we're going to plug in a 5, which means this would read 5 is greater than or equal to 0 plus 1, which is 1, squared, which is still 1. So 5 is greater than or equal to 1, which is a true statement. And when we get true statements, we shade the area that actually includes the test point that we used. So we got a true statement, so I'm going to shade the area that includes 0, 5. So inside the parabola satisfies all the points where y is greater than or equal to x plus 1 squared. Now we've got the other function we need to worry about. And this one, I picked this one because we haven't done this in a while. It's kind of complex. It's an exponential growth function. And remember, an exponential growth function usually does something like this, the parent function. And the key point is 0, 1. But something's happening to this equation or inequality. It's being shifted up 3. There's no left or right shift because there's nothing happening to the x. But there is an up 3 shift. So the key point, which used to be at 0, 1, would go up 3, and it would now be at 0, 4. So there's the key point. Now, just to help you draw the graph, remember there's something else that shifted also, and that was the asymptote. The asymptote is usually down here at y equals 0, but the asymptote shifted up, and the asymptote is now here at y equals 3. Now, this is only to help you draw the graph. Now, the next point, since this is a 2, you could plug in x equals 1 if you want to figure out where is the next red point on this graph. So plug in x equals 1. 2 to the first power is 2 plus 3 is 5. So 1, 5. 1, 1, 2, 3, 4, 5. It's right here. Now remember, this is an asymptote, so that graph can't drop below that line. And since it's less than or equal to, I do get to represent it with a solid line. So it's doing something like that. Now the next question is, where do I shade on this one? Well, since it's less than or equal to, you could do a test point if you want. But when it comes to just these curves, same thing with a straight line, with just a linear equation. Less than means below, greater than means above. So less than would be all the points that would be normally below this curve, this exponential curve. So all the points out here. And one more time, the true question is, where have I intersected the shading? What part of this graph got shaded both times? And here it is right here. Everything that's underneath the exponential, but inside the parabola. So pretty much right here. That would be your solution.